Hello, welcome back. Let's read more batteries about batteries. I'm uploading. I found one with a car battery. It's not car, they call it Automotive batteries. It's 1 p.m. soon. It's not so long, it's few pages. So I need to charge the camcorder. But this camcorder charges very fast. So let's read about it. I forgot to get something to drink, but this is not so long.
Automotive battery. A typical 12V, 40R lead-acid car battery. An automotive battery or car battery is a rechargeable battery that is used to start a motor vehicle. Its main purpose is to provide an electric current to the electric-powered starting motor, which in turn starts the chemically-powered internal combustion engine that actually propels the vehicle. Once the engine is running, power for the car's electrical systems is still supplied by the battery, with the alternator charging the battery as demands increase or decrease. Battery in modern cars. Gasoline and diesel engine. Typically, starting uses less than 3% of the battery capacity. For this reason, automotive batteries are designed to deliver maximum current for a short period of time. They are sometimes referred to as SLI batteries for this reason, for starting, lighting and ignition. SLI batteries are not designed for deep discharging, and a full discharge can reduce the battery's lifespan. 1. As well as starting the engine, an SLI battery supplies the extra power necessary when the vehicle's electrical requirements exceed the supply from the charging system. It is also a stabilizer, evening out potentially damaging voltage spikes. 2. While the engine is running, most of the power is provided by the alternator, which includes a voltage regulator to keep the output between 13.5 and 14.5 V. 3. Modern SLI batteries are lead-acid type, using 6 series connected cells to provide a nominal 12-volt system, in most passenger vehicles and light trucks, or 12 cells for a 24-volt system in heavy trucks or earth-moving equipment. For example. 4. Gas explosions can occur at the negative electrode where hydrogen gas can build up due to blocked battery vents or a poorly ventilated setting, combined with an ignition source. 5. Explosions during engine startup, air typically associated with corroded or dirty battery posts. 5. A 1993 study by the U.S. National Highway Traffic Safety Administration said that 31% of vehicle battery explosion injuries occurred while charging the battery. 6. The next most common scenarios were while working on cable connections, while jump starting, typically by failing to connect to the dead battery before the charging source and failing to connect to the vehicle chassis rather than directly to the grounded battery post, and while checking fluid levels. 5. 6. Close to 2/3 of those injured suffered chemical burns, and nearly 3/4 suffered eye injuries among other possible injuries. 6. Electric and hybrid cars. Electric vehicles, EVs, are powered by a high-voltage electric vehicle battery, but they usually have an automotive battery as well, so that they can use standard automotive accessories which are designed to run on 12V. They are often referred to as auxiliary batteries. Unlike conventional, internal combustion engined vehicles, EVs don't charge the auxiliary battery with an alternator instead. They use a DC to DC converter to step down the high voltage to the required float charge voltage, typically around 14 V.7. History. Early cars did not have batteries, as their electrical systems were limited. A bell was used instead of an electric horn, headlights were gas-powered, and the engine was started with a crank. Car batteries became widely used around 1920 as cars became equipped with electric starter motors. The sealed battery, which did not require refilling, was invented in 1971. The first starting and charging systems were designed to be 6-volt and positive ground systems, with their vehicle's chassis directly connected to the positive battery terminal. 9. Today, almost all road vehicles have a negative ground system. 10. The negative battery terminal is connected to the car's chassis. The Hudson Motor Car Company was the first to use a standardized battery in 1918 when they started using Battery Council International Batteries. BCI is the organization that sets the dimensional standards for batteries. 11. Cars used 6V electrical systems and batteries until the mid-1950s. The changeover from 6 to 12V happened when bigger engines with higher compression ratios required more electrical power to start. 12. Smaller cars, which required less power to start, stayed with 6V longer. For example, the Volkswagen Beetle in the mid-1960s and the Citroën 2CV in 1970. In the 1990s, a 42V electrical system standard was proposed. It was intended to allow more powerful electrically driven accessories, and lighter automobile wiring harnesses. The availability of higher efficiency motors, new wiring techniques, and digital controls, and a focus on hybrid vehicle systems that is high-voltage starter/generators have largely eliminated the push for switching the main automotive voltages. 13. Design. An automobile battery is an example of a wet cell battery, with 6 cells. Each cell of a lead storage battery consists of alternate plates made of a lead alloy grid filled with sponge lead plates, cathode, 14, or coated with lead dioxide, anode. 14. Each cell is filled with a sulfuric acid solution, which is the electrolyte. Initially, cells each had a filler cap, through which the electrolyte level could be viewed and which allowed water to be added to the cell. The filler cap had a small vent hole which allowed hydrogen gas generated during charging to escape from the cell. The cells are connected by short heavy straps from the positive plates of one cell to the negative plates of adjacent cell. A pair of heavy terminals, plated with lead to resist corrosion, are mounted at the top, sometimes the side, of the battery. Early auto batteries used hard rubber cases and wooden plate separators. Modern units use plastic cases and woven sheets to prevent the plates of a cell from touching and short-circuiting. In the past, auto batteries required regular inspection and maintenance to replace water that was decomposed during the operation of the battery. Low maintenance, sometimes called zero maintenance, batteries use a different alloy for the plate elements, reducing the amount of water decomposed on charging. A modern battery may not require additional water over its useful life. Some types. Eliminate the individual filler caps for each cell. A weakness of these batteries is that they are very intolerant of deep discharge, such as when the car battery is completely drained by leaving the lights on. This coats lead plate electrodes with lead sulfate deposits and can reduce the battery's lifespan by a third or more. BILA batteries, also known as absorbed glass mat, AGM. Batteries are more tolerant of deep discharge but are more expensive. 15. VRLA batteries do not permit addition of water to the cell. The cells each have an automatic pressure release valve to protect the case from rupture on severe overcharge or internal failure. A VRLA battery cannot spill its electrolyte, which makes it particularly useful in vehicles such as motorcycles. Batteries are typically made of 6 galvanic cells in a series circuits. Each cell provides 2.1 volts for a total of 12.6 volts at full charge. 16. During discharge, at the negative, lead, terminal a chemical reaction releases electrons to the external circuit, and at the positive, lead oxide, terminal another chemical reaction absorbs electrons from the external circuit. This drives the electrons through the external circuit wire, an electrical conductor, to produce an electric current, electricity. As the battery discharges, the acid of the electrolyte reacts with the materials of the plates, changing their surface to lead sulfate. When the battery is recharged, the chemical reaction is reversed. The lead sulfate reforms into lead dioxide. With the plates restored to their original condition, the process may be repeated. Some vehicles use other starter batteries. For weight savings, the 2010 Porsche 911 GT3 RS has a lithium-ion battery as an option. Winking sad smiley 17. From 2018 onward, all Kia Niro conventional hybrids feature one as well. 18. Heavy vehicles may have 2 batteries in series for a 24V system, or may have series parallel groups of batteries supplying 24V. 19. Specifications. Physical format. Batteries are grouped by physical size, type and placement of the terminals, and mounting style. 15. Amp hours, are. Ampere hours, are or a times H, is a unit related to the energy storage capacity of the battery. This rating is required by law in Europe. The ampere hour rating is generally defined as the product of the current a battery can provide for 20 hours at a constant rate, at 80 degrees Fahrenheit, 26.6 degrees Celsius, while the voltage drops to a cutoff of 10.5 volts, times 20 hours. In theory, at 80 degrees Fahrenheit, a 100Ah battery should be able to continuously provide 5 amps for 20 hours while maintaining a voltage of at least 10.5 volts. It is important to realize that the relationship between the R capacity and the discharge rate is not linear. As the discharge rate is increased, the capacity decreases. A battery with a 100Ah rating generally will not be able to maintain a voltage above 10.5 volts for 10 hours while being discharged at constant rate of 10 amps. Capacity also decreases with temperature. Cranking amperage, CCA, CA, MCA, HCA. Cold cranking amperes, CCA, the amount of current a battery can provide at 0 degrees Fahrenheit, 18 degrees C, for 30 seconds while maintaining a voltage of at least 7.2 volts. Modern cars with computer-controlled fuel-injected engines take no more than a few seconds to start, and CCA figures are less important than they used to be. 20. It is important not to confuse CCA with CA/MCA. Or HCA numbers, as the latter will always be higher due to warmer temperatures. For example, a 250 CCA battery will have more starting power than a 250 CA, or MCA, 1, and likewise a 250 CA will have more than a 250 HCA 1. 21. Cranking amperes, CA, the amount of current a battery can provide at 32 degrees Fahrenheit, 0 degrees Celsius, again for 30 seconds at a voltage equal to, or greater than, 7.2 volts. Marine cranking amperes, MCA, like CA, The amount of current a battery can provide at 32 degrees F, 0 degrees Celsius, and often found on batteries for boats, hence marine, and lawn garden tractors, which are less likely to be operated in conditions where ice can form. 22. Hot cranking amperes, HCA, is the amount of current a battery can provide at 80 degrees Fahrenheit, 27 degrees Celsius. The rating is defined as the current a lead-acid battery at that temperature can deliver for 30 seconds and maintain at least 1.2 volts per cell.